Asige class ina laws of motion 11 class ki portion dagi ni laws of motion sida kona maruena nainadu ji force ni force is kai haina define the way it is a push or pull which change or tends to change the state of rest or motion of a body. A body magi state of rest the lerambadu akoina rest motion da lehna honaba motion da lerambaduna rest lehna honarakpa dugumba external agent adu akoina force and defined the way. So this is inertia hena malaygo inertia of rest, inertia of motion, inertia of direction. Inertia is that we can classify it into three. Say inertia of rest, inertia of motion, and inertia of direction. Then what is inertia haitadi? Inertia of a body haitadi, the tendency of a body to remain in its state of rest or state of motion. Inertia haitadi akona body to gi magi tendency to remain in its state of rest or state of motion. Adu akona inertia kawi. Inertia makhan om to kaidok payai. Number 1 is inertia of rest, number 2 inertia of motion, and inertia of direction. So the inertia of rest haita gati akona say ko bus samda ko je pham say we are on say this is suppose this is a bus. A man is standing inside the bus. So drivers in a say driver suddenly suddenly bus e thaure thauda agadi hojiki bus manuga lepe ba mi si maning lom da tu ge taw kai gino haita di mi du ke tawre inertia of rest lerami suddenly my bus di move taw matam da suddenly lower part of his body start moving. Then magi body to say maning lom da to rei siwa kona inertia of rest kawi. Inertia of motion hargana so suppose a man is standing inside a moving bus, suddenly drivers in a brake suddenly brake si phare brake si pha matam da mi si mang lom da tu salli kai gino da mi si in the state of motion da lay suddenly bus gi brake apply to matam da kaidawi lower part of his body come to rest aduna masadi motion da lebanina kaidawi magi because of the tendency to remain in its state of motion sigi nupa si mang lom da tu salli so siwo koina inertia of motion kawi. Inertia of direction haita gati akona se lang amada nung amakire se nung ji yam kan unge suddenly unge se nung ji am kana unge se akona ungba kan da lang ji tat patar di ka dawi ziki nung ji tangential oina som da pai hi madu bo akona inertia of direction ka we. So now come to Newton's first law of motion. Newton's law of motion. Newton's law of motion is there are three laws of motion. First law of motion. So first law na haji kaino body ama rest laiba body ama rest adum laina honai motion da lerga na motion da dum laina honai adugi until and unless an external force is applied adu koina first law of motion ko. So everybody continue in its state of rest or state of motion until and unless an external force is applied. So Newton's first law of motion is also known as law of inertia. Law of inertia, and definition of force is given by Newton's first law of motion. Now second law of motion. Second law of motion. Second law of motion na haji kaino haita de suppose we consider a body of mass m. When a force is applied on the body, a force is acting on the body, then according to Newton's second law, the rate of change of momentum is directly proportional to the applied force. So that is, force is directly proportional to rate of change of momentum. So rate of change of momentum, or so momentum is mv minus mu. So this is change in momentum in time t. So F equal to m v minus u divided by t. So this is mass into acceleration. So rate of change of momentum is equal to applied force. So this is also known as second law of motion. Also we can in other notation, force is directly proportional to rate of change of momentum, or F equal to d by dt of mass into velocity. So according to Newton, mass is considered to be a constant. So this equal to mass into acceleration. Now, third law of motion. So according to this law, to every action, there is an equal and opposite reaction. So this is known as third law of motion. Now, from second law of motion, we can define the law of conservation of linear momentum. Law of conservation of linear momentum. So according to Newton's second law, force is equal to d by dt of momentum, that is rate of change of momentum. If f equal to 0, then dp by dt equal to 0, or p is a constant vector. Hence, law of conservation of linear momentum states that if total force acting on a body is 0, then linear momentum is conserved. So, ngasi akoina first law, second law, third law define tore, as well as inertia define tore, the law of conservation of momentum define tore. Mathangi video the sigi equations agatpa dagi magi application mayama mathang da lakani adu ngai minarasi. NEET G 2021 da thagadaba Satra Satri Singh Physics Online Class Yawning Bul Leragati Piriba Contract Asida Pau Pau Birakpa Yagani.